When you're taking notes here, I would recommend, again, this video is going to be posted, so if you just want to listen and watch along and not frantically copy down every single thing, because I am going to be going a little bit faster than normally in class, you can do that. If you just want to kind of sit back, copy down what you can, but then if you feel like you want to just kind of watch, please do that. Do not just goof off. I will be a little bit sad if you do. That's it. Let's jump into it. This is 10.6 segment relationships in circles. 3 different vocab words. We have chords, tangents, and secants. Let's get that started. This first example that we're going to go over uses the vocab word for chords. This is a chord, and also this is a chord. Okay. Well, here's the thing about this. If you have AE and EB, or EA and EB, those two are going to multiply to these two. It's an interesting theorem. Basically, when you multiply two segments, right, two parts of a chord, well, you're going to end up with the other two if you multiply them. So in example 1, let's take a look at how to apply this property. You're going to be solving for x like we normally do. So in this case, we have 6 times 6. That's the first pair that we want to do. Let's look at the second chord. Use a different color. We have 9 times x, or x times 9, but we're going to write the number in the front. When you multiply them, you can just write it as 9x. Well, 6 times 6 is 36. 9 times x is just 9x. Only thing left here to do is to get x by itself by dividing. Okay. So divide. You're going to end up with 4 equals x. And there you go. Bob's your uncle. Does anyone know that saying, Bob's your uncle? I don't imagine you do. It just means everything's hunky-dory, which just means everything's all right. I'm just going to move on. Next one, we have, again, same process. Multiply these two, right? 12 times 5. And then you can multiply these next two, x times 6. That's going to give you 6x. 12 times 5 is going to be 60. And then 6x just drops down. Well, again, we've already made the pairings that we needed to. All that's left to do is just simplify. That's going to give us 10 equals x, 60 divided by 6. Well, 10 should be your answer. You may notice, if you plug it back in, that these numbers don't add up to each other, right? 10 plus 6 is 16. 12 plus 5 is 17. Not the same numbers. But again, it's about whether or not they multiply to each other, right? If this is 10, well, 10 times 6 is 60. And then 12 times 5 is also 60. Okay. Last one. Again, not rocket science. We have x times 8. That's just going to be, we can write it as 8x. And then we have, again, 10 times 12. That's going to be equal to 10 times 12. The order doesn't matter. That's going to give you 120. And then if you divide both sides by 8, that's going to give you x equals 15. Okay, pretty simple first 3 examples. Okay, in this next example, we have segments of secants theorem. In this case, we have 2 secant lines, which basically means that the lines cut through the circle. Well, in this case, the formula is pretty similar. You're going to be multiplying this segment with the entire segment. That's what this is saying. And then you're going to set it equal to this segment times this entire segment. That's basically what it's saying. I will help you guys out to understand what that is. There's a little nifty example from the textbook if you want to take a look at that. As for us, we will jump straight into the examples, okay? Again, this is the examples for 2 secant lines, 2 lines that are crossing into the circle territory. It's not just grazing the outside of it. So let's take a look. I'm going to highlight the outside 2. Okay, those outside 2 are the ones that we're concerned about. You can start this problem in a different way, but I like to just construct the skeleton of the problem. So we have 6 times a giant block equals 7 times another giant block of text. Basically, at this point, it's just going to be this entire length combined that goes in here, 6 plus x. Okay, just imagine 6 and x combined to go in here, 6 plus x. So let's do that. And then on the other side, we have these two combining together, 7 plus 5. Okay, I'm just going to write the step for now, but you can simplify that. In fact, if we write on the next line, let me write that down. 7 plus 5 is just 12, right? You mean you could have distributed, but that's a little bit harder. On the left side, we can distribute because this is a variable. 6 times 6 is going to give you 36. 6 times x is just 6x. Let's keep simplifying. This is going to give you 36 plus 6x equals, I do recall that should be 84, right? 7 times 12. And then from here, it's just a matter of simplifying. Subtract, subtract. These are going to cancel. 6x is going to equal 48. Okay. And again, at this point, it's just dividing. X is equal to 8. And this is going to be your answer. So again, notice what we did. What we did was we took 6 times 7, right? That came from here. And then we took the whole thing. We took the whole thing, right? Placed it right next to it right there. Okay. We'll do another example, okay, in case that wasn't clear. So zooming into the second one. Again, this guy and this guy. You can choose to go out of order if you want. Let's actually just go in order. So 8, right? And 9. Again, we're just creating a ratio between the two sides. So in the left side, you're just going to get 10 and 8, right? 8 plus 10, rather. Same thing. So 8 plus 10. And then on this side, 9 plus x can go in the next set of parentheses. 9 plus x. Okay, well, if you simplify, again, you can distribute if you want. It's just not the easiest way. Why not just add these up first? So that's what we're going to do. 8 times 18 is equal to, on the right side, because we do have variables, I think it is easier to distribute. I mean, there's not much you can do otherwise. That's going to be equal to 81, 9 times 9, plus 9x. If we continue simplifying, this is going to give you 144 equals 81 plus 9x. Simplify by subtracting 81 from both sides. So that cancels. You're going to be left with just 63 is equal to 9x. And again, just a matter of simplifying at that point. Okay. This is going to give you 7 equals x. Okay. So let's do one more. Normally this is going to be on you guys, but I'm not there. So I'm going to help you guys do it. This is going to be 9 and then 8. You can go out of order if you want. If you want to fill in the parentheses first, you can totally do that. I don't know why. I like to just have the whole thing out. So this is going to give you 9 plus 7, right? That whole line. And then the whole line here is just 8 plus x, right? 8 plus x. So let's do that. 8 plus x. You can distribute if you want, but as usual, I'm going to just simplify that. That's going to be 16, right? And then on the right side, I will distribute. That's going to give us 64 plus 8x. Ugh. 9 times 16, what's that going to give us? Well, that is going to give us 144 is equal to 64 plus 8x. If we simplify by subtracting, well, that should give us, let me move here, 80 is equal to 8x. Simple stuff. Divide by 8 on both sides. That's going to give you 10 equals x. Cool? So that's example 2. Again, if you plug it back in, you shouldn't expect it to add up to the same numbers, right? These aren't going to add up to the same numbers, but it should follow the proportions that we have here. Okay. This is the last example. The only difference here is that we are using secants and tangents. So one line that crosses through and the other one that doesn't cross through a circle. So for example, in this case, a secant, take a look. I know you're not listening right now. Listen. Secants are going to be this line right here. Tangents are going to be this line right here. Notice how it doesn't cross through the circle. It just grazes it. The formula for that is actually very similar, except it's going to be this right here. Let's take a look as to what that means. So these are secant and tangent lines. I'm just going to highlight the tangent line. Okay, just to show which one is kind of obvious. That one's a tangent line because it only has the one. It doesn't cross through the circle. Turns out, according to our formula, we're just going to square it, right? You could take a look at the formula up here, right? We're just going to square that tangent line, and then it's going to be equal to, very similar to the same process as before. Take a look at just a single line. That's going to be 8 times both of them combined. 8 plus x. Again, that's going to be just 8, just a little segment on the top, that secant line, and then the entire secant line added up together. Okay? Well, let's remember our exponent rules. 12 squared, that's just like saying 12 times 12. That's 144. It's not 24. And then you're going to multiply this across. That's going to be 64 plus 8x. And then from there, just subtract 64, subtract 64. 144 minus 64 is going to give you 80. And then if you have 8x, you're going to divide. In this case, 10 is going to be equal to x. Okay. We'll do it again. Take a look. We have 6. That is our tangent line. It doesn't actually keep going across. So that's going to be 6 squared, right? 6 times 6 is just 6 squared. And then that's going to be equal to 4 times 4 plus x. Just have the entire highlight right there. 6 times 6 is 36. We know from distribution that these two are going to be 16 plus 4x. If you subtract on both sides, these are going to cancel. You should end up with 20 equals 4x. Well, dividing both sides by 4, well, 20 divided by 4 is just 5. 5 equals x is your answer. Okay. Last one. Which one's our tangent line? Which one's the one that we have to square? Well, it's going to be this guy right here. So let's do 12 squared is equal to, again, take the outside one that says 9, and then let's add up 9 plus x. 9 plus x. There you go. At that point, just distribute. That's going to give you, that's going to give you 144, right? 12 squared is equal to 9 times 9, 81, plus 9x. Subtract 81 on both sides. 144 minus 81 is 63 equals 9x. If you divide both sides by 9, 7 is equal to x. That's it. Goodbye.